New York City, one of the greatest cities in the world, also known as a city that doesn't sleep. But do you know who else doesn't sleep? Engineering students. NYU Tandon School of Engineering is located in the heart of Brooklyn, aka downtown Brooklyn. The civil engineering students are working tirelessly each day to implement the best management practices to aid in the interconnection of stormwater networks that will in return allow for storage to use in off-peak times, reduce erosion and contamination, and so on. Our project goals include reducing stormwater runoff, improving air quality, improving people's mental health by increasing the presence of green space, and most importantly, to inspire people to research and perform sustainable practices through education. Here are 5 methods we have come up with to design, implement, and educate. Method 1. Rooftop rain gardens. We propose implementing rooftop rain gardens on the Dibner Building roof and Jacobs Building's 4th floor terrace. Rooftop rain gardens perform multiple functions that are critical to improving the environment and the health of building occupants. They improve water quality by intercepting and retaining 50 to 90% of stormwater runoff, thus reducing the occurrence of combined sewer outflows and returning the peak flow closer to pre-development levels. 2. Urban rainwater harvesting.
We want to implement rainwater harvesting tanks to collect the excess rainwater from the roof of Dibner and Jacobs. Each 10,000-gallon tank will collect and store water for usage or release later. There will be 3 tanks used to collect the excess rainfall from the Dibner building and 1 tank for the Jacobs building. Stormwater is a resource, not a waste product. The rain collected will be used to water the vegetation on campus and in the Metrotech Commons instead of just going down the drain.
3. Downspout disconnection.
Downspout disconnection is the operation of redirecting rooftop drainage pipes into rain barrel cisterns or permeable areas. The set locations for the disconnection will be Rogers Hall and Dibner Library. We will have 2 points of disconnection at all site locations. By rerouting the runoffs to pervious areas, overland flow time increases and the peak flow will be reduced. The vegetated and pervious areas can help filter runoff and increase water quality by reducing quantity.
4. Bioswales.
The general approach to determining the location of the bioswales was finding the location in Metrotech Commons that were close to roadways and various parking garages. We intend to place a total of 12 bioswales that will be 10 foot by 5 foot standard right-of-way Type 3 bioswales. Signage around the bioswales are proposed in order to prevent the community from touching the vegetation in the bioswale.
And 5. Revegetation and porous pavements.
In this project, we decided to use native plants in areas where there are existing soils to not only increase the area's biodiversity, but also to further reduce the site's runoff. And in areas where there are no existing soils, porous concrete, which has the highest surface permeability in the market, will also be used to reduce the site's runoff.